Hello everybody, Brad the Guitarologist here. In this video episode I have a Mesa Boogie Dual Rectifier Roadster amplifier. Usually I don't feature modern amps, but this one was kind of cool because of the way I picked it up. I got this on Craigslist as a non-working amplifier for peanuts. And when I say peanuts, I mean really peanuts. The guy even threw in an extra foot switch, still in the plastic. So I have a brand new extra foot switch. Apparently this thing, he thinks, has a bad output transformer. So we're going to dig into this, pop it open, test the output transformer, see if that is indeed the case, and see if if it was just maybe unplugged from a load that caused it or something else. So if that sounds like something you'd be interested in, please stick around. If you're familiar with Mesas, one of the things that makes these usually a nightmare to work on is just they have a switch and a button for every single possible thing you can think of. They're sometimes really overly complicated. This one, for instance, I mean, these are nice though, I mean, because they have independent settings for your reverb on each channel. This is a 4-channel amplifier. We have a couple of broken off knobs. We may have to replace some pots. I don't know. There might be enough there to grip the knob back on. I've got another broken off one over here for the slave level. And we will replace those, but I mean those are small issues. I did get this amp without tubes as well. That was the other issue, but I've got plenty of tubes. I can retube this from my current stash. So yeah, we'll see if we can get this thing working and have an amplifier that we can either play or resell or whatever, and not have a whole lot of money in. So let's pop this thing open and test the output transformer and see what's going on. All right, here we are with this thing open, and there are no real visible problems I can see, which is a plus. That means there's no catastrophic fire or anything that took place here. This is just a failure of a component. This guy did say he took this to one of the local techs, a shop that I'm aware of that does a lot of business, and they said that the output transformer was definitely bad. And they wouldn't know, what else might be bad unless they went ahead and ordered the transformer and tested it from there, which is reasonable enough, I suppose. But we're going to check the transformer to see if it is indeed bad. So first things first, let's find where the leads terminate, and they should be at, let's see. I don't know if I'm going to have to pull some boards out or what, but let's explore this a little further. Here are the speaker jacks on the back of this thing, and the board that they're attached to is where the wires come through. This would be the secondary, and you can see there, there's a lot of just crustiness around those leads, and maybe there's some little problems going on there, maybe. But that'll at least give us some test points to test the secondaries of the output transformer, and also we can test these jacks. Sometimes it's just a simple case of a jack being corroded or bad, or maybe even bad solders or something on them. But let's check those, make sure that's not the case, test the output transformer, and we'll go from there. All right, well, this is super interesting. Actually, at first, I tested this output transformer, and I was surprised to find that it actually worked, or everything seemed continuous, and it looked like everything was going to be fine. So I fired off a text to the guy I got it to. I said, "Hey man, this amp is actually the output transformer is actually good on this, I think." And I said, the place you took it to, you might be skeptical of in the future because, it looks like this thing is fine. And then I measured it again on a whim. I said, just I guess to satisfy my own mind. And then everything was shorted between the black, which is the common wire, and each one of these was all shorted to common or ground. So I was like, well, what the hell? It was, I know for a fact it was fine a bit ago. So I said, well, all right, obviously it's not fine. So we're going to desolder all these secondaries and desolder the primaries, which are here and over here. Whoop. Yeah, there, and then the center tap is over here. But I was going to desolder it, unscrew it, and take the output transformer out, and order another one. Well, when I went to desolder the black, it came out just fine. Went to desolder the green, I went to pull the wire out, and not only did the wire come out of there, but it also came completely out of there. So some kind of damage has occurred right here. Alright, here's the output transformer out on the bench, and we can see here's our green secondary lead, and there's where it tied onto. And it's just been sheared right off. What a strange thing. See, it got part of the black wire as well. Okay, now that we've got this thing out, we can also go ahead and test it. I've hooked up the leads to the secondaries. First, we're going to start with this yellow, and we're going to measure by dialing up the primary. I've just got it kind of jerry-rigged up here on the desk. So let's start out with really low power. I mean, really low. And see if we measure anything on the secondary. Uh, 1.7 volts AC. There's 3.4, so it's following the variac. Look at there. I'm up to what, 25 volts on the variac. It's kind of hard to do one-handed, but you can see there I'm able to dial it up and down. Here's the down. So let's turn that off. Okay, so the yellow is not only continuous but working. Let's try this one. Yeah, this was definitely shorted, and it was causing the problem. No doubt about it. I would say let's dial this one up. Yep, there we go. We're good there. Alright, and the green one. The green one's going to be a little tough. Let's dial it up first, just a little bit. Alright, there we go. About 5 volts on the secondary. We'll remove it from the brown and just touch it to the green. Look at there. I'll be damned. This transformer works. It's just I mean, how many times do you ever see that? Alright, 2 little pieces of shrink tubing later, and we have a working output transformer. On the Roadster, and also some other Mesa Boogie amplifiers as well, when you're removing the chassis, you actually have to remove the chassis partially from the back and unplug the reverb leads after removing the chassis partially. That is probably why the leads for the output transformer, because this is the output transformer, that's probably why those leads were severed. Somebody did not realize you needed to do that, and they were trying to get like a knife or something up in there to release the reverb leads, because you can't reach around the other side. You just can't reach those leads. So you have to actually pull the chassis partially out and do it this way. And probably what they were trying to do is get up there in there with some kind of knife or something, and they ended up severing one of those leads. So that would explain that. Alright, well, we got the output transformer all soldered back in. It's back in. We've got this board back in. We've got our knobs back on, the ones that had been broken off. And I think we're ready to put some tubes in this thing and slowly dial it up on a variac. Alright, I've reinstalled the output transformer in this Roadster and going through and testing it, hooking it all back up, and the amp is completely dead. Well, the tubes light up, we've got power, everything seems to be fine. I've tested, just spot checked, you know, the power here and there, and the voltages all seem to be okay, but we're getting no sound at all. So we're going to have to go through and do some signal tracing and see where we're dropping sound. And for that, we're going to look at the schematic. Now, some of these stages, V1 is fine. This one's fine. Some of these stages are cathode followers, so you got to be real careful about where you put your probe if you're doing signal tracing. Let me give you an example. Here, for instance, V3B, there's 210 volts on the cathode here, and there will be a high voltage on some of these as well. Pin 7 also will have a high voltage, 214 volts. So you got to be real careful about where you put your probe expecting to hear sound, because you may just burn up whatever equipment you're using to signal trace. So we're going to go through and see where we're, try to figure out where we're dropping sound. Now this thing has a bunch of JFETs in it, and those basically are in this amplifier acting like little switches. We see a couple examples here. Here's a J175, here's another one. And what they're doing in this particular position is they're turning this part of the circuit on and off. They're doing it here as well, and here as well. When voltage is applied to this pin, the third pin, that's the center leg, it will turn this FET on or off depending on whether voltage is present. So there are a bunch of these in here, so we're going to have to consider those two, and those are going to be pretty hard to troubleshoot if it ends up being something like that. So let's just go through and see where we're losing signal. We'll do some signal tracing first. Also, along with the schematic, I found there are a couple of service bulletins. One of those deals with a resistor that needs to be installed in the power supply, so we'll go through and do that. I'll show you exactly where that needs to go. And also there is a actually, this gives you some more information on where it goes. Also, there is another one about dropouts when you're trying to switch channels and so forth, and there's something that you can do to mitigate that after the thing is warmed up. When you're trying to switch channels, if it's getting delayed or if it's not switching right, there's something that you can do for that. So we'll go through both of those service bulletins also in this video. Okay, one of the service bulletins deals with early versions of the Roadster and the inability of them to switch after heated up. The foot switching becomes a little clunky or a little delayed, and apparently that's down to a couple of components. You see where this ribbon is clipped on here? If you have an early one like I do, revision 1, 2, or 3 version, you need to remove this cable from this clip, come in here, and this little transistor right here, it's too close to this component. This component is a 5-watt component, and it gives off a lot of heat. This component's actually labeled 6426. But see how close that little guy is? You just need to bend this further away, like so. And supposedly that will solve any issues with the amp not switching channels smoothly or quickly after warming up. And when you replace this ribbon cable up under here, make sure that your ribbon cable is free from the chassis tension screw here, which comes up through the bottom of the chassis. Service bulletin on the Mesa Boogie Roadster is to solder in a 220K resistor from the middle large blue capacitor here, positive end, over to this first capacitor here, the positive end. Just solder a 220K resistor between the two. Okay, I was talking to my buddy who is, again, an authorized a boogie repair guy. He said these little FETs right here are always suspect, and these are on the effects board. And I've measured across these. A couple of these are for muting. Like I think it's this one right here. These are J175s. These parts are pennies, but when they go bad, they can cause this sort of problem. But for the most part, all the little transistor components that are in here, these, you know, these are very sensitive to any kind of spiking. And if we've had any other problem, those will just, you know, those will just crap out. And apparently, it's a common enough problem that you know, the guy I know who works on Mesa, he said, you know, it's common enough. He stocks those all the time because he very often just shotguns all of them in these amplifiers when he gets them for this symptom, this sort of symptom. So yeah, it's going to be kind of a big job to replace all those, but that's the plan. I'll get online and order some of those, and then we'll continue this video hopefully someday in the future. Alright, I'm back here with this Roadster. Been doing some troubleshooting. I've got my J175s in, and I've replaced quite a few of them. I've replaced all the ones on this board, and I've replaced those two right there, and also that one back there. So I've replaced most of the ones that I thought might have been suspect, or I thought might have, you know, caused the symptoms that I'm seeing, which is a very, very reduced output. And the thing is, it's reduced output across all channels. And if we look at the schematic for this thing, okay, here's what we're kind of looking at. We have an input, comes in, goes to V1A, and I've signal traced all of this out so far, and I get signal at V1A, which is pin 2. Whoops, sorry about that. I get signal on that pin 2 right there on V1A. So obviously we're fine there, which I knew that anyway. I get signal also on pin 7 over here. So everything's good up to that point. Now there is a switch here which feeds the second channel, or excuse me, channel 3 and channel 4. So channel 3 and channel 4 are over here, and they get mixed back in here before V1B. And I'm getting signal for channel 1, 2, 3, and 4 right here at this point. So everything from here over is fine. And just to demonstrate that, I can show you what I've got going here. That's a probe that I'm using hooked into my amplifier back there, and we'll just put it on put this thing on channel 1 for now, and you'll see how reduced. And this is cranking. I'm cranking the master volume and the channel volume all the way up on channel 1. That's the extent of our output right now. And that should be just blasting us out of the room at that volume level. But if I take my probe, and let's see, let's hit a note here. Okay, so we're actually getting signal back there on that one. We're getting signal here as well. Let's see. I should probably hook this up to an iPhone or something, make it a little bit easier. Okay, now that's V2A. So we're getting a lot of signal at V2A. So that gets us up to this point, and we're getting a lot of signal on V2A from all channels. Let's just skip to, say, channel 3 and check channel 3 real quick. Let's see, we have to actually turn the thing up. Let's turn up channel 3. Actually, it looks like it's making a liar out of me right now for some reason. And I'm not sure why it would be. Why isn't it get? Oh, that's why. That's why, because it bypasses V2A. So excuse me. I'm only getting signal from 1 and 2 right there, because this other one has a switch. Yeah, okay. That relay actually switches and goes somewhere else. So pardon me. Channel 3 and 4 go somewhere else and bypass that. But I am getting signal from channels 1 and 2 at that point. So that means everything from here over is good. Now let's go to the next page where this one goes to what is that, R51, and this one goes to V2B. So let's go to the next page of our schematic. And let's see. Alright. V2B, that's channels 3 and 4. V2B. Alright, if we come up here to V2B, let's see, let's hit a note. Okay, so that means for channels 2 and 3 we're good up to this point for sure. Now let's go back up to channels 1 and 2 and trace this out. Now here's where we're getting into our master volumes and our presence controls, and this is kind of the weird thing now. You'll see here the signals come in depending on which switch we have closed. It'll either go to channel 2 or channel 1's master volume to one of the legs, the leg that is not hooked to ground, which will be this one here and this one on channel 1. So that leg right there on channel 1. Let's go back to channel 1 just to make it a little simpler. Now, if I hit a note and check here on the master volume, we get signal. Let's actually turn up the channel a little bit. Let's see, actually that channel's cranked. So that already is a little bit suspect because that channel's, oh, that's why. Because I have this, I think, well, let's see. You see that? Okay, we're definitely getting signal there. If I turn the volume, master volume all the way up, however, and I try to measure right there, I get nothing. Nothing at all. So something is not right on this master volume somewhere. It's getting pulled directly to ground. So what I'm measuring with the resistance, this would be maximum resistance from wiper to ground. So at maximum resistance from wiper to ground, I'm getting nothing here. So it's very, very puzzling. But at any rate, I've established that everything is good up till right here, this master. So I'm going to go through and check this component. It's probably a waste of time, but I will check these components. There's no reason for all 4 of them to be bad. So something is going on with the masters, and all 4 of them are doing this. Okay, I think this should perfectly illustrate the validity of my theory here. We're going to start with the master volume pot from the wiper to ground, and we're going to measure that. Right now we're at 7.5K, and this is with the amp off. Okay, we'll dial the dial the thing a little bit. Okay, so we go from a low, you know, up like we should. There's damn near a meg there. So 800 and something K, 900K pretty much. All right, so that's what we about expect. That's what we should see. Now watch this. Whenever I turn the amplifier on, okay, just simply the act of simply flipping the switch. Let's turn the variac on and see what happened there. Without touching anything else, the reading jumps all the way down to 57 ohms. And we can check every other channel in this amp. Let's just jump over here to channel 3. Okay, so there is the wiper of the master volume on channel 3. Right now, without that channel selected, I'm getting 274K. Let's see if I can adjust it. Okay, I can adjust it down to 33 ohms, all the way up to 242K. But let me switch it to that channel, channel 3. Okay, now it's on channel 3. Jumps down to 56 ohms. So what's happening is the switch is working, but the switch is it's working, it's doing something, but what it's doing is not right. Either the problem is in the switch, which I'm beginning to kind of doubt, or the problem is with an associated component around the switch. So let's look again at the schematic and see what we might be able to figure out about this. And I also need to try to locate that switch, that relay on this board. Okay, so I've had this thing out and open for a little while, and have been doing some more troubleshooting on it, and I've isolated this down to something in the mute circuit. I've lifted the legs of a couple of these JFETs, J175 and MM and J175 MO. By lifting those legs, I have made them, basically lifted them from ground so they can't mute this amp out. And that has actually brought the amp to life. The problem is, you know, it's not working fully the way it's supposed to, because that mute circuit has a function. It actually prevents you from having loud pops whenever the amp is switched. So this is, you know, we're obviously going to have to fix this, but the amp works. Every channel works. Everything sounds killer. When you switch the channels, though, you get a loud, really loud pop. And I'll just kind of show you what I mean here. We'll see. All right. Hear that loud pop? You will get that when you engage pretty much anything. You're going to get a pop. Whether you're engaging the effects loop or the switching channels or engaging reverb. If I had the foot switch on, you would see that as well. There would be a pop every time you hit the switch. You get this loud boom pop, just like that. So that's what this mute circuit's for, is to mute that. And by lifting those legs, I'm preventing the mute circuit from working, but I've actually made the amp start working. So there's some more things we need to look into, but I think I've pretty much isolated it down to just a couple things. So we're real close to having this thing done. Okay, I just got off the phone with Mesa Boogie Tech, and we were talking about this schematic, and I'd already replaced most of the JFETs in this thing, including these here, the MM, the MO, and the LM, and those are shown elsewhere on the schematic, and I'll show you where those are. Let's see. Let me find those really quickly. Sorry. Here's one of them, for instance. And as you can see, here's what happens. This is the input coming into the effects loop. There is a bypass for the effects loop. Okay, and that's there's a relay that switches that goes to the bypass or goes through the effects loop. Now, there is also a mute circuit that momentarily, and I mean like in nanoseconds, mutes this point right here while the switching is taking place, so that it prevents a pop from occurring, a real loud pop, and that would happen in live situations, and that's obviously not something you want if you're in the middle of your solo and you're trying to engage your effects loop. So you don't want that. So what they've done is they've designed this with these JFETs, these J175s, and one of the legs of the JFET, the middle leg, is connected to this point in the mute circuit, and I'll show you again. It's connected to this point. Now, whenever there's voltage present right here, and you can see there's a 12-volt supply, whenever this is engaged and drawing voltage and there's voltage present right here at this point, the MM, the MO, and the LM, all three of those little JFETs will be engaged, and therefore they will not be continuous circuit to ground, such as right here. You can see here, in their natural state, there is very little resistance between this leg of the JFET and this leg of the JFET. There's only like 50 ohms or something like that between those two legs in their natural state without voltage on this third leg. When voltage is applied to this third leg, it's like somebody grabbing the water hose and preventing the hose from preventing the water from getting from one side of the hose to the other. And that has to be, there has to be voltage at this point in order for that clamping to occur, in order for the signal to get out through the rest of the amplifier. Now this is in one of the main lines, so if it doesn't go from here to the other side, and if it's all going to ground right here, then you will get no signal. And if you have a Mesa Boogie with this sort of problem, this might be what you're looking at. You might be looking at a situation where either these JFETs are bad, which George has told me is very common for these JFETs to be bad in the amps, or it's a situation where you have something else going on in the mute circuit, and that's what I was talking to George about, because I had already exhausted the possibility that it might be those JFETs, and because I had already replaced those with new JFETs, so I was pretty confident those would be okay. And it's something in this circuit. So he's giving me some things to look at here and to test for. One of these legs, if we can remove, for instance, the 6426 leg from here, and if the voltage appears suddenly, then we have isolated it down to something, you know, from here over, most likely that 6426. Now, he did say the 6426s are pretty robust and they very rarely go bad, so I'll take his word for it on that, and I'm not looking for that to solve the issue. But if I remove one leg of the 6426, I would expect to see 12 volts right here at this point, and consequently at all these other points. He also said that the RM1, the RM2, these two JFETs right here could also be suspect, and by removing the center leg of these, we can test whether or not the voltage appears, because that would be also drawing down the voltage through there. So there's a possibility that, or from up here rather, so there's a possibility that that is one of these is also causing, and these I did not replace. So I think first things first, I'm going to, because this is the easiest thing to do, I'm going to remove the leg of the 6426P, because that leg is very exposed. These little JFETs are kind of crammed in. I'll show you what I mean. Here's the amplifier. Here is the 6426, and you can see here I've already been doing some testing on it. That's why it's kind of, and I'll clean this up obviously before I'm done. But you can see here the leg is a little more accessible, and this is the one that in the service bulletin they said push it away from this component right here. So I've done that, but I don't think that has anything to do with it. It could have been that it was so close to that component all along that it just burned it up, or did something like that happened. But we're going to remove that leg right there to see if our 12 volts appears right here. This resistor right here, that second one from the left right there, that's a 1.5 meg. The 12 volts exists on this side, but not on that side. So on the bottom side nearest to us, that 12 volts is right there, but the 12 volts does not exist up there, and you can see the trace comes around and goes right there. We're going to lift that leg and see if that voltage appears at the point on the trace on the board right there, or or we can measure it over here on this lead also if we want. And of course it would go over to our JFETs as well. We could measure them and see if the 12 volts exists there then. The other option would be to start with these down here, and they're a bit crammed. These are the reverb JFETs, these two right here, that one and that one, RM1 and 2. Those control the muting of the reverb, so when the reverb's engaged, it doesn't make that loud ass pop. So these two we're going to test also if it turns out not to be a problem with that 6426. So let's check the 6426 first, and then we will come back and move along to these two. Alright, I've lifted the leg of that controlling transistor right there and measuring the board at that point, and getting no voltage still. So the problem is not with the 6426, and it lies probably elsewhere. So what I'm going to do, I'm going to go through and start clipping the center legs of each one of these JFETs, and I guess just kind of go from there. Alright, I've clipped off the center leg of all 5 of those related FETs, the ones that are related to the mute circuit. There are 2. There's J175MM, there's MO right beside it. Over on the backboard back here, there's one that's connected, and that's J175LM. That one's been clipped, the center. And of course we had the 2 over here that were related to the reverb, and I've clipped both of those. Furthermore, I also have the leg of the controlling transistor lifted, so the transistor essentially is out of the mix, and on this side of that resistor right there, I still show no voltage. So we've got something else going on in this circuit that's pulling down the voltage. Let's move along maybe to anything else that's going to ground from this circuit, and we'll look at that stuff. Alright, in the circuit we have a couple of other components that could be at fault. We have a 0.1 capacitor right here, C78, and we have a 2.2 microfarad cap right there, C44. So let's locate C78 and C44 also. We also might lift one leg of this resistor right here and just check that it's the correct value. I doubt that's a problem, but I suppose it could be. So yeah, pretty much anything on this side now that's showing us a path to ground, which is pretty much down to these 2 capacitors. Alright, I got one leg of that 1.5 meg resistor lifted out of there, and that resistor is fine, so that's not the problem. Let's move on to those caps. Alright, there's C78. I've pulled one leg of it out of the board, and it is where it's supposed to be. That's supposed to be a 0.1, so here's what we've come down to. Here's what I've tested. I've lifted one leg of this resistor. It is good. I get 12 volts on this line right here, just fine. I do not see 12 volts right here. The reason I do not see 12 volts right here is because there is a clear path to ground from this spot somewhere. I have removed MM, MO, and LM completely from the circuit, so they are not even in the amp anymore. I have sucked all of the solder out. Okay, so there's no blobs or anything like that. I've sucked all the solder, they're gone. The only one I've left in is this, I've left in the LM right here, but I can actually isolate that one down by disconnecting this ribbon right here. Okay, so that one, by disconnecting this ribbon, and let's go ahead and do that while I'm thinking about it. Alright, now LM is no longer in the mix. So, That eliminates these three components. No way for the signal to get to ground through there. Right? Okay, agreed. I have lifted legs on each of these components and tested the components themselves to make sure they're not shorted. They are not shorted. So that's the other two paths to ground right here. There's another path to ground here through the RM1. The middle leg, which is this leg, is clipped. So basically the RM1, this one should be completely out. Same with this one. Those are completely out. Normally there would be a path to ground through those, but they have been clipped and those paths no longer exist. So where else is available? Okay, I have finally solved the issue of this thing, and the issue was with this little JFET right here. I had replaced it when I replaced those two, and this one over here, or well, not the one, but the 3 or 4 that's on this board. I replaced. I was just basically going to go through this amp and shotgun all the JFETs, and what happened was I had one. I mean, these are so small. You can see right there just the tip of my thumb, or the tip of my finger right there. This is not my thumb, obviously. Tip of my finger, and how close together those are. Well, one of those was just barely bridged across when I installed it, and that was the problem. So that was the path to ground. This is getting grounded elsewhere on the schematic. So that part was my fault. Now initially this thing had other problems as well. And I think it had to do with some of the JFETs on this board. Probably this LM. I think the LM that I pulled off of here was bad, and maybe one of these was bad if I recall correctly. But when I reinstalled and was shotgunning these, I got that one wrong and accidentally shorted it slightly. So I've gotten rid of the short. So we're going to reinstall all of these transistors and fire it up, and I think that's going to take care of the problem. Fingers crossed. I know I'm jumping the gun saying, oh, got a solution, but I can show you what I mean, why I think that I have found the solution. And that's because when I test this point right now, where I should, before I was showing a direct path to ground, now I have about 1.5 megs, which is precisely what I should be seeing. So, and that's with none of these FETs in. And as soon as I took this one out, that was the only change that I made. When I measured before that and after that, and that was the problem. So I'm pretty confident I've found the issue, and hopefully we will be able to seal this one up and find a new home. Alright, sure enough, here we are with the Boogie on and running. We are checking our 12 volts where we are supposed to see it, and we do have our 11 volts. We do have our voltage at the spot we expect to see it. So let's see if we get sound when we expect to get it. Take it off standby. And let's see. Sorry for the bad camera work. Alright, dudes and dudettes, that concludes our service on this Mesa Boogie Roadster. Hope you guys have enjoyed the video. I also want to thank you guys for sticking around so long. I'm just about to, as of this date, pass 1 million total hits on my channel, so that's a big milestone for me. Also just passed over 4,000 subscribers, which is awesome. I think we're up to 4,200 or something like that now. So we got a really cool community going now, and got a lot of good comments. And I always appreciate you guys' comments and watching and everything. And you know, if you enjoy this sort of thing, you know, for instance, my last video was probably the simplest 1960s vintage amp you could possibly get, and today we're doing probably one of the most complex modern amps out there. So you never know what you're going to get on this channel. So if you haven't already done so, please hit the subscribe button below. Also want to take a moment to thank George at Mesa Boogie. His help on this was really invaluable. He spent quite a bit of his time today with me, and I really do appreciate that. You know, got nothing but good things to say about Mesa as far as their service goes. They've always been good to me. I used to deal in them years ago. It's been quite a while now, but they were always good to me, and they always stood behind their products. You know, we did have some things that had issues here and there, but they always were Johnny on the spot as far as trying to get things sorted. And this one's well out of warranty, and he spent quite a lot of time with me on the phone today. So, I mean, you can't ask for more than that. So I appreciate that help from Mesa Boogie. Also want to give a shout out to my friend Tony Doris at Volition Amplifiers in Evansville, Indiana. That guy is really cool. If you guys are anywhere near that area, near the Evansville area, you should take him your stuff. He's a wizard. I've learned a lot from him, and I appreciate all of his help and advice that he gave me on this project. So thanks to those guys, and thanks to you guys, and for now, y'all take care.